Hello, I'm Rafal. I came from Poland, from Krakow. I work as a software engineer at Google. And today I would like to tell you about continuous delivery, focusing on the practical aspect. So today we will build a full continuous delivery pipeline from scratch using Spring Boot, Jenkins, and Docker. Everything I know about continuous delivery, I learned from two persons. One is this guy, the guru of the continuous delivery, because he wrote this famous book, which is kind of a Bible about continuous delivery. Has anyone of you read this book? I really recommend it. And the second person, why I know so much about continuous delivery, is Misha. Misha, she eats a lot. She consumes enormous amount of food. Just to be clear, it is this fairy lady on the left. And because she consumes a lot of food, I have to spend a lot of money on that. And you know that pet food is quite expensive. And I thought how to balance my expenses, and thought that the best way to do it is to get a discount at the pet food store. And I thought that the easiest way to get a discount at the pet food store is to get hired as a developer. And that's how I joined the company called Voxxed. This is certainly just a joke, but really Voxxed is a great tech company running a pet commerce store. And they are doing this transition now, which many companies does, from monolith application, rewriting parts of it into microservices. And where there is microservice, there is continuous delivery. They go always together, like flip and flap or peanut butter and choco. They are always together, and so basically we develop microservices, and we had to develop the continuous delivery pipelines so that we don't need a million of operations people to get into the production. But what exactly is the continuous delivery? So by definition, is the ability to get changes, features, configuration changes, bug fixes, experiments into production, into the hands of the user safely and quickly in a sustainable way. That is the definition from this book, from the book. But definition, it doesn't tell us much. 3 weeks ago, I was traveling in France with my dear friend, and we were traveling in the northern France, driving car, and I told her that I'm going to give a workshop on continuous delivery. And she asked me, what is continuous delivery? And then I had to challenge myself to explain to non-IT persons what the continuous delivery is. And I went this way. Imagine that you have a product like your Gmail. You would like to have a new feature in Gmail, like when you send a message to someone and someone receives the message, you get a notification when it's ready. So what do? You go to the developer, like me, and you ask, could you implement a feature for me? I answered, yes, sure. So I implement this feature in 1 day, and then, in a normal process, I have to give it to the QA team. They spend 2 weeks testing this. Then I have to give it to the operations team, which will really put the code into production. And then, after 3 months, you can use the feature. In the continuous delivery, as soon as I finish writing the code, it goes through the automatic tests, right into production, and you can use your feature right away. So continuous delivery is this one turbo button that will bring your code into production in a safe manner. I know you've heard about the story about the Aquan figure. Yahoo bought Flickr some time ago, and it was a collision of two cultures. Yahoo was a big corporation with a very long delivery process of 3 months, and you know, a lot of QA people, a lot of operations, all this. And Flickr was kind of a startup, growing startup, and they really did continuous delivery. What they called, it was in the production very soon. And when Yahoo bought Flickr, they told them, come on guys, you are no longer software cowboys, now we do a real software. And by that time, you know, Flickr, they were releasing really frequently. They even had in their footer on the page the time of the last release. And even the pictures of the people, so that you can, you know, who to blame for the bug. And what happened? The Yahoo was bigger, they could force Flickr to change their delivery process. So they changed it to 3 months with QAs and everything. But what happened is that there were, in the result, there were more bugs, not less. How is it possible? Imagine that you've created a bug in your code. Maybe not you yourself, because you wouldn't do it, but let's say your friend created a bug. And imagine that your code goes the same day into production. So what happens? Customer is angry, your boss calls you in the evening and says you have to come back to the office, so your kids are crying, your wife is shouting at you, but okay, you pack your backpack, pack your laptop, you go back to the office. And how long does it take to fix you the bug you've created the same day? Probably not a lot. Probably it will take you half an hour and you are done, go back to your kids and family. Now imagine that you have to fix a bug you created 3 months ago. It really takes a huge amount of hours. I remember fixing such a bug. I used to work in a banking industry, which has a huge, heavy development process, and it took me 2 weeks to fix one bug I did 3 months ago. So that is how the traditional delivery process looks like. You may know it from your experience, or if you are lucky, you just know it from my story about Yahoo. So how it goes? Customers, they give the requirements. Then there is the brilliant agile team of developers, and they do everything very quickly, you know, agile, scrum, everything, deliver. Then they give the code to the QAs. They are testing the code. Then the QAs give it to operations, and the operations go. They go with the code into the production. And all we want to do is now automate this process. How do we start? So we always start from continuous integration. And the continuous integration is the easiest point to start because it's in our hands, in the hand of developers. How many of you has the continuous integration in your teams? Yeah, that's for most of you already have it, so you are on the right track. There are many different ways to monitor your pipeline. Some teams there have monitors that you enter the office and all of a sudden you know if your trunk, your master is green or red. There's even a good idea to monitor this. I don't know if you've seen that, but you can build your own pipeline UFO and hang it under your ceiling, and then when you come to the office, you just know all of a sudden there's even some sound generator, I think. So there are a lot of cool things about how you can monitor your current pipeline, continuous integration pipeline. There are also many tools. Today I will show you an example in Jenkins, but it doesn't matter which tool you use for your continuous integration and later for continuous delivery. They are all good. It's not about tools, it's more about the idea. So, we have the continuous integration. We have to automate the two last steps, which is much more difficult because it involves changing also the people. What can we do with QAs and this QA phase? We can use automated tests. By automated tests, I mean not unit tests. This are probably you're already doing in your daily work, in your continuous integration, because why would you run continuous integration otherwise? But by automated testing, I mean automated acceptance testing, automated performance testing. So after this test, you should be sure that the code is doing exactly what you want. So instead of people like clicking here and there to check if your web page is working, you can have a Selenium test to cover the scenario. So the idea is that you put exactly the same what people would do, but it will be covered. When we have this acceptance testing, and also performance testing is sometimes necessary, we can think about how to automate the last step, so IT operations. We can do it with configuration management, so that we don't need a bunch of people configuring our servers and maintaining our infrastructure. But we can have less people and use some smart tools like Chef, Puppet. Here I will show Docker. Docker helps a lot. It's not the same as Puppet, but it solves sometimes the same problems. And the automatic monitoring. A lot of teams have it to enter the office, and you have one screen with your continuous integration, the other screen with your Kibana logs, and see how your system in production is doing. Having these three steps automated, then we can have a continuous delivery pipeline. So the continuous delivery pipeline is a sequence of scripts which gets your code from your repository and put it into production. So everything you have to do between your commit, the repository, and releasing this to the production. And we can think now how, in a moment, we will build such a pipeline for the the simplest possible pipeline for the simplest possible project, just to have like an MVP of continuous delivery. We can think how the steps should look like in the simplest continuous delivery pipeline. What we did in Zooplus, like the starting point of the project, was always this pipeline. First step was always to check out the code from repository. Then we compile to check if there are any compilation problems. Then we run a unit test to check if there are anything that we do unit test. Then we deploy to some testing environment, usually called staging. Then we run acceptance tests. Here you can also run performance tests, whatever you want, over the staging machine, against the staging machine. Then after the step, we should be sure we are ready to release. So the next step is basically to release it to the production. And at the end, we run the smoke test, which is usually a subset of acceptance tests, very small subset, with literally one test run against production, just to check if the release went okay. So we're gonna implement it now. We would like to have like this pipeline, just that button and have it in production. I've chosen Spring Boot. It really doesn't matter what tool you use for developing your project. I've chosen the Spring Boot because it's cool. And it saves your time. It's what Java needs for a long time, because it allows you to create your Java application literally in 5 minutes. So now what we're gonna do, we will build an exchange rate application, which will give it a currency, exchange rate web service. We will give it a currency, and it will return the exchange rate. So let's do it. So to start a Spring Boot application, the easiest way is to go to the Start Spring.io website, choose the Gradle or Maven project, then give it a group ID by the Maven convention, and give it some name. Cool thing is that we can choose all the dependencies we want from Spring. Here we will use just web, because we just create a very simple web service. Then we can extract it, and we are ready to get it into IntelliJ. So we import this into IntelliJ, or Eclipse. Oh, who uses Eclipse? So in a moment it will be imported. The best thing about this is that when you just download it, the application does nothing, but you can already run it. So you can run, and it has an embedded Tomcat server inside it. It creates a jar with embedded Tomcat, so we just run it right now, and you will see in the log that Spring application is starting. Spring Boot uses convention over configuration, which means that it has default values for everything. So even if you don't set everything, it works. For example, for here you use port 8080 by convention, and you can run it. We will create a simple controller, like exchange controller, with one method, exchange rate. This exchange rate will take the currency and return the exchange rate. Good thing about Spring Boot is also that we don't need to write any configuration file for that. We'll just write the method, annotate it, and it will work. So here in the case of USD, we will return 0 because we calculate the return rate to USD. And for else, let's say for now it's not supported. As I mentioned now, the last thing we just have to annotate it with, this will be REST web service, so with REST controller, and to map the endpoint to the right place, we just have request mapping, and we'll give the endpoint we want. So now we will run the application, and you see it's all we have to do to have a working application. And when I work in Zooplas, that's what we did. That was the first starting point. Write a skeleton application, kind of doing nothing, and create a continuous delivery pipeline for that. So we can see we run it. You can go to the local host 8080 / our currency converter, and we have a nice result on 0. Web service is done. Now if we want to have a continuous integration, we need a unit test, because otherwise, what do we test? So let's write the simplest possible unit test for that. We will use JUnit, but doesn't matter. You can use any library you want. You can use Spock, you can use any unit library. We write a simple scenario that should return 1, 0 when the currency is USD. The Gradle is smart enough to know that when we will use Gradle for unit testing, it is in a pipeline, so we will realize what is a unit test by scanning all the test directory. Okay, we have given currency USD. When we call we have to create the controller. When we call the controller, what we expect is 1.00. It's the hackpath scenario. It would be enough to have this application and to show how to build a continuous delivery pipeline for this project. Okay, so we need assert equals, we need some imports, and we are ready to run it. First, let's run it locally. It should work. Since it's a movie, I'm sure it works. Now we have to share it on GitHub or any other repository, not really matter, but I will use GitHub here. And so let's import this into the repository, and we are done with the first step. So we have already our first Spring Boot application in the repository, which is working, and it's 5 minutes. You can even see it in my GitHub. What we're gonna do now, we will build a continuous integration pipeline for this. Yeah, it's here. So first, how are we gonna build it? So that's the most basic continuous integration pipeline. So we have our developer machine, we developed the code there, that's what we did. We pushed the code into the repository, and that's what we did. Now we have to have a Jenkins with the server with the Jenkins installed, and Jenkins will pull the code and execute the first 3 steps, like classical continuous integration, which is build, compile, and unit test. So let's do it. We go to the Jenkins, new item, we give it a name, Vox. We select pipeline, so we want to go to a pipeline. Click OK. And the cool thing about Jenkins 2 is that this is a Jenkins 2 that we can write everything in a script. So we no longer have to click a lot of things, because nobody likes clicking, everybody likes writing. There's even a hello world example. So each step is called stage. We give it a name. First will be in our case checkout. The checkout we pull code from the GitHub repository. I'll check the GitHub repository address here. And we are done with the first step. Next step will be build. So using Gradle, so we just executed, you can from script, this is a Groovy script by the way, and you can execute anything you want with sh. So we execute Gradle just to build classes, it's Gradle in assembly, and then we will just compile classes without executing unit test. Yeah. And the last step will be unit test, which is in Gradle terminology is Gradle check. And we are done with the continuous delivery, the continuous integration pipeline. Let's just run it, see if it works. You will see that it goes step by step. Why we don't write just one script? And because we would like to know in which step failed. Our reaction will be different if we cannot check out from the repository. We don't even need a developer to fix it, because probably there's some internet connection problem. If the problem is in the build, it means that touch compiles, so the problem is very easy. And the unit test, yeah, it's a little more, you have to dig inside this. So, yeah, wait just a second more, and our unit test should be done. So we are done with the first continuous integration pipeline. Let's do a short mental exercise here. We have our first 3 steps. How could we implement the deploying, staging, acceptance test, release, and smoke test? Since we script everything, we could do everything, basically. The easiest way to do it, and that was my first approach, was to write just SSH, SCP, copy the jar, run on the server. And you could do it the same. Actually, in my first company I worked in, we had just Unix scripts. Actually, it was one script deployed, one script deployed to staging, one script to release, and we just run it. But what problems can we have with such an approach? So first, we have to take care of every server, because it has to have its own environment. Also, we have to be very careful to have the staging and production in the same state. If you are interested in the problems you can have if your staging environment is not exactly the same as production, I really recommend reading a book called Release It. It's one of the best books about such topics. So we can have different Java, and the application can use the same port, obviously, because we use 8080. So we will have to change it in the application. And also, if we copy this in a naive manner, we will have always the same version there. So we will not have versioning. And how to address this? It's the last part of in the introduction. We already see Jenkins, we already see Spring Boot, and now it's Docker. By the way, Docker, I think they have the best IT logo I've ever seen in the software industry. It's just cool. So, just short introduction about Docker. Let's say I would like to run my application on a production server. So what I usually do, I send my jar or work to ITOps, and they run it. But if I send two applications, I may have a problem, because maybe one application is written in Java 7, another in Java 8. In Java, it's not that bad because Java claims to be backward compatible. But you can have different dependencies on some Python, which is not backward compatible, on a lot of different libraries, which we can call together an environment. So just the environment can be needs to be set differently for application 1 and application 2. It gets even worse when you have a lot of applications and a lot of servers, like farm servers. Then you really don't want to configure each server to cover this particular application. And before introducing continuous delivery and Docker in Zooplus, we really literally had a server for Java 7 and a server for Java 8. So the idea here is to treat your servers like cattle, not pets. So each server, you should not care about the server. Server is just, each server is the same, different machine, but you should treat it exactly the same. How to do it? And here comes the concept of virtualization. And that is how VirtualBox, I will start from VirtualBox because I think everyone knows VirtualBox. This is how it works. So we have our operating system. On top of that, then we have VirtualBox host. And each image is a full operating system. So if you would like to use VirtualBox in our production, we could do that, but we can have two problems here. First, the image size is very big. It can be 2 gigabytes, 3 gigabytes. Just not convenient to store it and to send it over the network. And the second problem is the speed. If you ever worked on the VirtualBox inside it, it's not so fast as your real operating system. And Docker is just improved this idea. So they created a Docker engine layer, and now your image is without operating system. It's just application plus your dependencies, plus your libraries. And that way it's faster and it's smaller. So addresses all our concerns about virtualization. So, Docker, it seems perfect for continuous delivery, because look, we create on our machine, we create Docker image, and it goes through the pipeline, and in every environment in the pipeline, it works the same, because we deliver the whole image, so it must work the same. You will never be again able to say like, it works for me, but it doesn't work for you. It just works on every environment. That is why it's perfect, because when we test it on Jenkins, it will be the same when we test it when we run in production. How to create a Docker image? So we just create a Docker file in our project with that's minimum, so 3 lines. First, we specify which is the base image for our image. So we build an image on top of another image, and we download it from the internet. Then we add our library, and then we run it. We commit this Docker file to repository and run docker build, and our image is built. How to run image? Running image is called container. So container is an image running, so it can have a state. Image is something we send, so it's without a state. And to run it, we just docker run, give the container name, and give the image you would like to run. Docker registry is something like it's repository for your Docker images. So just storage for all your Docker images. It's like Nexus for Docker. So you version your images and you put it in one place. So that later, if you would like to roll back, you can just get old version and run the old version. Docker image should have, there is a convention for Docker image name. It should always be the registry address / image name, and you can add, after the colon, also you can add version. Docker push, it pushes your image to the registry. Docker pull takes the image from the registry to your Docker. You can have port mapping, so you can map the port from inside the container to outside the container. And you can run your Docker on the external host. So it's like running the same command on the external host. So a short example, it would be run the Docker image code. This is the last part is the name on this host with the port mapping 8080 to 8080. Run it as a daemon, so it means that we will not be stuck at the console waiting for everything that happens, and give it a container name exchange rate. And now we're going to implement it. So that will be our workflow. We develop the code in our machine. We push it to GitHub. Then the Jenkins pulls the code from GitHub. It does all the continuous integration, so checkout, build, unit test. Then it builds the Docker image. Then it pushes the Docker image to the Docker registry. Then it triggers staging machine to take the Docker image from the registry and run it there. Then we perform all set of tests against the staging machine. Then if we are done with the test, we triggers the production to pull the image from the registry, and lastly the smoke test against the production. And that will be our minimum viable product for working continuous delivery pipeline. So let's do it. We're starting from this continuous integration point, and we just have to extend our pipeline. So it's groovy, so we can define the variables. So for the convenience reason, we will define all the IP addresses of the registry, staging and production, so that we don't make a mistake later. If you think about it, the groovy is great because it has all the features, so it's very convenient to write it right here. And now we can add the additional steps. So first will be Docker build, so we build the image. It's as on the slide, you just write Docker build minus Docker build image, minus the image, We have to define how the image would be named. As I said, by the convention, it's always the registry name, then the name what we want, and then the version. There are different methods of versioning. You will just use the build number, but you can use hash code, you can use this versioning from Maven style, like 1.00, etc. Then we push it to the registry, which is just Docker push and the image name. Then we are ready to deploy it to the staging. So we just run Docker, give it a host name 2375 is the default port for Docker host. We map the port to the 8080 to 8080, and we run it as a daemon with the image name, and we can give it a container name. And a variable which we will define in a second. So we already have this is already on the staging environment. Now we can perform the acceptance test. What would be the simplest acceptance test? Normally you write as a JUnit suite, but here we don't have it, so we will just use the easiest possible, so we'll just curl the endpoint and see that the result is 100. But in a normal case, you just write whatever you need in some frameworks like Cucumber, Fitness, or just JUnit, or Spock, whatever you like. There are a lot of good frameworks for acceptance testing. We have to sleep 60 seconds because all Docker commands are executed asynchronously, so we don't know when it really started. Sleeping is not so nice, but I'll tell you how to do it better in a second. So our next stage is release. So at this point we are sure that we can release to the production. And as you can imagine, it will look exactly the same as for the staging machine, which is a very good sign because we should do exactly the same for production than what we did for the staging. And the last part is the smoke test, which in our case will be exactly the same as the acceptance test because our acceptance test is small and the smoke test should be a subset of the acceptance test. Okay, then it seems that we are done with the pipeline. And so we are ready to go and see how it works. So save and build now. So first three steps are exactly the same, so we will see them again running. But basically what you see that it's like build is quite fast and also unit test is quite fast because all native dependencies are already there on Jenkins. So we don't, it's like compile this few lines of code is basically nothing. Now the next step will be, we will build the Docker image. And what is interesting here, which you'll see in a second, that it was very fast to build a Docker image and to push it to registry. Okay, pushing, it depends on your network. But Docker build is really fast because it's just take the other image and just add what you need for your image. Deploy to staging is also very fast, but we wait this 60 seconds. Sleep is always like a sign for developers that something is not so perfect. And what can we do better? There's no very good solution because this Docker, SH Docker is run asynchronously. So what we can do is just write a loop, trying to, each second, trying to contact the endpoint. And it will be a little better because then we don't have to wait always 60 seconds. And also, you know, if your machine is busy, then it will be more than 60 seconds. And even that is a solution, I think, advised on the Stack Overflow with this loop, so it's not so crazy that we will loop it for requesting every second. We are done with acceptance tests. You see, acceptance tests, it's quick because it's just one curve. And now we're releasing, so it will take another 60 seconds. What is, again, cool about this script, that we wrote it as a script, that we can put it all as a Jenkins file to a repository and keep the pipeline configuration together with the project. And that's what you should do, because how you release your project is part of the project. So your project now, it's a full thing, from building functional stuff to the release. So we need to wait another 5 seconds, I think, or 10 seconds to see the release. I remember I was doing this workshop yesterday, the same thing as a workshop yesterday, and all the people managed to configure the continuous delivery pipeline. And when when tried to debug what was wrong, they were all of them were just staring at the computer. It was so interesting to see like these green boxes turning green. So it was like watching better than watching a movie. So okay, we are done. So that was the MVP of continuous delivery. So my main message of this talk is to you is that it's very easy, and it's the first thing you should do in your project is to set up a skeleton project and run and set up the continuous delivery pipeline. Thank you.